Okay, so what is RVLM? RVLM is nothing but a rostral ventrolateral medulla. RVLM is rostral ventrolateral medulla. Yes, RVLM is rostral ventrolateral medulla, which is located where? Located in our medulla oblongata. And this RVLM or rostral ventrolateral medulla, this is tonically active center. What is tonically active center? Tonically active center, that means it remains active always, even during the period of sleep. So RVLM is a tonically active center. Yes, RVLM is a tonically active center. It remains active always. Okay. And RVLM, this is actually related to sympathetic system. Okay, sympathetic system, that means thoracolumbar system. Yes, thoracolumbar system. Look here, neurons coming from RVLM is released at the level of spinal cord, where thoracolumbar means thoracic level and lumbar level of the spinal cord. Okay, thoracic vertebra and lumbar vertebra. Yes, because why? Because RVLM, this is actually related to our sympathetic neuron, sympathetic outflow. Okay, fine. So look here, what is IML? Do you know what is IML? Yes, intermediolateral gray column. This is IML. Intermedio, I for intermedio, M for medial, I for inter, M for medio, intermedio, L for lateral, intermediolateral gray column. So neuron arising from RVLM is really at the level of thoracic vertebra or lumbar vertebra, because RVLM is totally related to our sympathetic nervous system, that means thoracolumbar system. Okay, fine. Then preganglionic sympathetic neurons goes to sympathetic ganglia, and then from the sympathetic ganglia postganglionic sympathetic neurons are arising. And what is the action of sympathetic system on our cardiovascular system? Sympathetic system, postganglionic sympathetic system, via neurotransmitter norepinephrine, it activates the action of heart, it activates the cardiac output, activates the contractility of heart. Okay, and also constrict the blood vessels, that means vasoconstriction. Okay, so RVLM, rostroventrolateral medulla, from RVLM through bulbospinal pathway, neurons reach up to spinal cord, and then from spinal cord to our sympathetic ganglion. This is called our preganglionic neuron, and this is bulbospinal pathway. Now bulbospinal pathway, it is totally activating and using the neurotransmitter glutamate. So the neurons of bulbospinal pathway, which are arising from RVLM, rostroventrolateral medulla, and relay at the level of spinal cord, they are glutaminergic. Yes, and then preganglionic sympathetic neuron using acetylcholine, ACH, and then postganglionic sympathetic neurons, they are using norepinephrine increase the cardiac output, increase the blood pressure, increase the contractility of heart, and also constrict the vessels and increase our blood pressure. Okay, so RVLM, rostroventrolateral medulla, is totally related to our sympathetic system, sympathetic outflow or thoracolumbar outflow. Okay, fine. And it increases the blood pressure. Okay, fine. Now what is the action of the carotid sinus? Look, here is the carotid sinus. Look here, this is the carotid sinus, and in the aortic arch of aorta, there is also some baroreceptors, but now we are focusing on the carotid sinus. So blood pressure is increased inside the carotid sinus. Blood pressure increased inside the carotid sinus, causing the distension of the wall of the carotid sinus, and this distension is sensed by the baroreceptors, those who are located in the wall of the carotid sinus. Which layer? Tunica adventitia. And then from this baroreceptor, the stretch sensation from this baroreceptor which are located on the wall of the carotid sinus. They are carried via sinus nerve of Herring's to where the ninth cranial nerve. Okay, that means in between carotid sinus and ninth cranial nerve there is a little small nerve which is called carotid sinus nerve or the sinus nerve of Herring's. Yes, and then from ninth cranial nerve is this impulse goes to nucleus tractus solitarius area of the medulla. NTS, N for nucleus, T for tractus, S for solitarius, nucleus tractus solitarius of the medulla. And this ninth cranial nerve, this is glutaminergic. This also secretes glutamate. Okay, that means this is activating nerve. Okay, fine. And this glutaminergic nerve relay at the level of NTS, that is nucleus tractus solitarius, and from here another nerve from nucleus tractus solitarius, another nerve originating, and this nerve reach up to CVLM. What is CVLM? That is caudal ventrolateral medulla, and this is also glutaminergic. Yes, but the nerve which is arising from CVLM and relay at the level of what? Relay at the level of RVLM. This is totally inhibitory. Okay, that means this nerve, our ninth cranial nerve, is activating or glutaminergic, which is activating in nature. Okay, and then a nerve arising from nucleus tractus solitarius, this is also glutaminergic and this is also activating in nature. Yes, but nerve which is arising from CVLM or caudal ventrolateral medulla and relay at the level of RVLM, that is rostral ventrolateral medulla, this is totally inhibitory in nature. Why this is inhibitory? Because this is GABAergic. Okay, and GABA, it is an inhibitory neurotransmitter which causes the hyperpolarization of postsynaptic neuron and inhibits the postsynaptic neuron by hyperpolarizing the postsynaptic neuron. And if GABA is inhibitory neurotransmitter and it inhibits this bulbospinal pathway, then bulbospinal pathway is inhibited by GABAergic neuron which is arising from CVLM, and then what happens? This bulbospinal pathway is totally inhibited, and then whole this sympathetic chain which controls the cardiovascular system, this sympathetic chain which controls our blood pressure, which controls our cardiac contraction, our cardiac output, all of this system is totally inhibited. Okay, that means RVLM, it is tonically active, that means always active when you are sleeping. Even at that moment, at that period, RVLM is also active. Okay, it activates via bulbospinal pathway to our thoracolumbar outflow. That means RVLM is totally related to sympathetic system, and sympathetic system is causing our increased cardiac output, increased blood pressure and vasoconstriction. Okay, fine. That means RVLM, it activates the heart rate, it increases the heart rate and increase the blood pressure. And when blood pressure is increased excessively, this RVLM is inhibited by our CVLM via GABAergic neurons. Okay, then CVLM inhibits the RVLM, and then whole this thoracolumbar outflow system is inhibited. Okay, fine. So how this RVLM is inhibited? So RVLM is generally tonically active center. That means it remains active each and every moment until or unless it is inhibited by our caudal ventrolateral medulla. Now look here, the carotid sinus. So blood pressure inside the carotid sinus is increased, and these stretch sensitive receptors are located in the wall of the carotid sinus are sense this increased blood pressure, and this sensation is carried by carotid sinus nerve up to where? This ninth cranial nerve, and then from ninth cranial nerve it activates our nucleus tractus solitarius area of the medulla via glutamate neurotransmitter. Okay, and then this nerve arising from nucleus tractus solitarius and relay at the level of caudal ventrolateral medulla, this is also glutaminergic. This also activates this GABAergic neuron which are arising from CVLM and relay at the level of RVLM. That's why these GABAergic neurons actually inhibit the RVLM center, and whole the sympathetic chain is inhibited and blood pressure decreases. Same action is done by also our vagus nerve. Okay,